Will we start with those three? Yeah. On the page 128. Yeah, maybe we'll start with those three. Binomial 10, 11, 12. Yeah, let's have a look at that. So, okay, well, we'll have a look at them now. My computer's gone a bit slow. Okay, here we go. Yeah, so I think we were saying that the answers are wrong for those three. We need the table book. Okay. Oh, Michelle, you need one of these table books too.
For 12A, I used the way, but it was close enough to the correct answer. There was neither the answer in the book nor the answer I asked.
Huh? What are you saying?
I used the way for 12A, and it wasn't the answer in the book.
Yeah, well, I'm going to do it now. I'm just trying to find my pen. Here we go. Sorry. Okay. It is known that 55% of births are boys. What is the probability that in 30 births, most are boys? So that's the probability. So most are boys in a group of 30 means 16 or more. So that's 16 or more boys. Okay. But the problem is boys is 55%. So yeah, it's outside our table. So we need to change it into to girls. So 16 or more boys is 14 or fewer girls. Isn't it? Yeah? No, 14. Yeah. And we need to look up P is 0.45, N is 30, and X is 14. So if we take out our old table book and on what page is it on? 14. Go down to 0.45 and 14. 0.6448. Okie dokie. Right. Continue. A fair coin is tossed 20 times. The number of heads shown is small. Find the value of x so that the probability of observing this event is less than 5%. Maybe I should have been a little bit clearer. So what I'm picturing is you have P is 0.5 and you have N is 20, and I'm looking for some number so that I can say the number of heads less than this number is equal to 5%. I shouldn't have really said less than 5%, I should have said is 5%. So we need to go to our table for 20, which is on what page? Do we have a table for 20?
Yes, we do. Page 12.
So 20 and 0.5, and we're looking for when we get 5%. 4 is pretty close, but it's a little bit too big. So maybe that's 4 is too big, isn't it? Oh no, sorry. No, it's 5 is 6. 6 is too big.
Yeah, the answer in the back is 6.
Yeah. But I guess 6 is closer than 5, because you have 0.0577. Yeah. close. I'll just go. What did I go at the back?
6.
I went with 6. Yeah, I'll go with 6. So the probability of getting 6 or less heads is about 5%. But I think what I'll do is I'll change the percent in the question to 6% to make it a little bit easier to read. So it's just using the table backwards. I tell you the probability and I wanted the number. Yeah. Yeah. All right. Continue. Cutting it tight, Mubarak. 12 now. A pin is made of 4 random digits. What's the probability of seeing a pin code with at least 1 0 in it? So you have 4 digits and at least 1 0. So at not actually a C problem, at least 1 0. That's equal to 1 minus probability of not at least 1 0, which is another way of saying probability of no zeros. So, how many numbers here are not 0? 9 out of 10. 1 to 9. You have 9 out of 10 possibilities. And here, 9 out of 10 and so on. So this is 1 minus 9 over 10 times 9 over 10 times 9 over 10 times 9 over 10. So that's 1 minus 81 squared over 1 0 0 0 0. I don't know, 64 something, whatever. Maybe someone can just tell me. I'm tired. Total? 0.3439. Now, is that what I had at the back? It is, but it's the second part that's wrong. Okay. Continue down. So what you do is you have 30 people and you want to know what's the probability in this group of 30 people. At most, 5 of them will have a pin number like this. So what's the chance of getting a pin number like this? It's about 34. So you're using your table now, where the closest value you can get is 0.35, the n is 30, and the x is 5. Yeah.
5 or less, yes.
Yeah. Yeah.
So just less than 5.
Less than or equal to 5. Yeah. Right.
So, if you look at the less than 5, wouldn't it be just less than 5?
What are you asking me? I'm not sure.
No, if you look at the table at x equals 5,
Yeah.
then you're just looking at probability that
It's 5.
less than 5.
Less than or equal to 5, I think. The table includes the value that you look up. So if you look up 5, you're looking at 5, 4, 3, 2, 1, and 0.
Oh yeah, okay.
Where's my
I was
table?
not looking at I got confused between this number.
0.0233.
No problem, no problem. 0.35, 30, is it? And what number? 5. So that's 0.0233.
It's funny, I got the same answer with that one. With the NC problem.
Really? Are you sure? Okay, okay.
Part A was obviously not the same, but part B was.
Okie dokie. Right, that's that one. So what else will we need to see now this morning?
And the next page, question 14.
The next page,
Yeah,
question
14.
14. You think the answer's wrong? Or
I'm getting a slightly different answer.
how slightly different?
It's 0.9104.
And what's the answer to the back?
0.9153.
Not too concerned. Okay, let's have a look. You want between minus 1.5 and 2. Minus 1.5 and 2. We want this area. Okay, so the answer will be the value of 2 minus the value at minus 1.5. You can't look up minus 1.5, but there's a trick. You can change this into 1 minus 1.5. So that would be equal to value of 2 plus value of 1.5 minus 1. Now, let's, what page is that table book on? 9. So if I look up 2, I get 0.9772. If I look up 1.5, I get 0.9332. So if I add them together, I get 4, 7 and 3 is 10, 11, 18, 19, and then minus 1, 0.9104. That's what you got too. But my answer at the back is 0.53. Oh, that's a bit more different than I would like. But I would have used a computer program to do this, so I'm not sure. I must have mistyped something. Okay, so this one here, what number is that? 14. That should have been, yeah. Okay, that's a bit weird. Right, what else now?
Can we do 12?
On which, same page?
Yeah. And then 17.
12. 12. Okay. 12. So for this one, it's between, what is it? Between
Minus 1.5 and minus 1.
minus 1.5 and minus 1. So that's table book value of minus 1 minus table book value of minus 1.5. Okay? That's 1 minus table book 1 minus 1 minus table book 1.5. So what happens is the 1 and the minus 1 cancel. So it ends up being table book 1.5 minus table book 1. So I actually have those values written down earlier.
No, you have 2.
Oh, I do? Okay. What's 1.5, so you can read?
1.9232
And 1?
is 0.8413.
Don't we always subtract the number on the right from the number on the left?
Just 1 second. %. Now, what are you asking me?
Don't you always subtract the number on the right from the number on the left? Because the minus 1 was on the right, but then when you flip the sign. Because I was thinking the probability of 1 minus the probability of
Are you happy with this line?
Yes,
So what's wrong with going with this line?
nothing. The next line. I thought they're supposed to be the other way around.
Oh no, look. That's minus. So there it is, there's minus. Minus 1 and 1 cancel. And then minus 1.5 is plus 1.5.
Yeah, and then 17 is difficult.
Mm. 17, okay. Question? No? Actually, so I don't forget, let me just take attendance. The heck is this? Which group is this? This is it. Okay. Right. Michelle, I have Abir, Autumn. No. Celine? No. Sophia? Yes. Mubarak? Yeah. Shadira? Mohammed? Sabrina? No. Moza? Angela? Ahmed? No. But you'll be in? Safra? And Neil. So I'm missing 6 people. Autumn, Celine, Sabrina, Ahmed, Safra, and Neil. Okay. I seem to be permanently missing 6 people from this group. Like I was missing 6 people yesterday and 6 people the day before. Okay. Right, what one did you say next, Mohammed? Huh? 17? Okay, let's have a look at that. Z will be more than X 8.08% of the time. Find X. So what I'm saying is, there's some number here, which I call X, and your chances of being to the right of it is 0.0808. So we need to have a probability that our Z is bigger than or equal to X to be equal to 0.0808. That's another way of saying that the probability that Z is smaller than or equal to X, smaller than X, is 1 minus that. What is 1 minus that, please? 9192. Okay. We know that to calculate this, we just have to look up the formula book at X. Hey, do you need me or them? I just did the attendance. There's 6 absentees. Do you want names or? Okay, Grant. Okay, so as I was saying, we need to look up the table book so that we get an answer of 0.9192. Is 1.4? Okay. Is that the answer at the back? Right, okay. Let's see. Okay, what's next now? Huh? On that page? Is it? Did anybody get, I'm just curious, on the binomial page 126? On 126, did anybody get number 12? No? Okay. I really like number 12.
Wait, how did you get from the
Let's see. Huh?
If you go back to the last
Yeah.
question,
What you have to do is you have to look backwards. So you need to look into the table for an answer of 0.9192. Apparently that's at 1.4. Right?
okay,
Yeah.
makes sense.
It's exactly.
Yeah.
Okay, number 12. So you have a group of 2n people and they're evenly split on whether they should give the teacher a pay rise. You join the group and cast your vote 2. What's the probability your vote will matter? Okay. So I'll do something similar to this to give you the idea. Imagine you have 10 people. You don't know which way they'll vote. Probability that they'll vote yes, we'll say 0.5. Okay? You are going to be the 11th person that joins them to make a total of 11 people. Now, you don't know how the other 10 people will vote. Maybe they'll vote yes, maybe they'll vote no. But first, we want to calculate what is the probability that your vote will make a difference. So what's the probability that you will have what's called the casting vote, the tie-breaking vote? In other words, that your vote will matter. Well, we talked about this in class before. If 10 people are voting, when will your 11th vote make a difference? Yeah, there's a tie, yeah. So that's 10C5, 0.55, 0.55. So what is that, please?
Is it 11? Because you count yourself.
Oh, sorry. Oh, no. We're looking at just these 10 to know if your vote will make a difference as the 11th voter. So what is it there? 0.
Oh, 0.246.
246. Okay. So now we get a little bit more interesting. Your vote may make a difference. How often will it make a difference in this situation? 24.6% of the time. So about 25% of the time your vote will make a difference. Now, somebody can bribe you. They can give you some money here. You want to know what's a good amount of money to give. So it depends on how much a yes is worth. So let's say, like in my example here, I was saying people are voting yes on a pay rise, but it could be anything. Like maybe another example would be this is a committee of 11 people, and they have to vote on whether they build a new hospital or a new school or whatever. And the builder, of course, would like them to vote yes. So the builder would feel like, well, if they vote yes, that's good for me because that gives me a profit of 10,000 euros if they vote yes. If they vote no, then I don't get to build the school. Okay, so we can think of this as a tree. Either it will pass or it will fail. So in this group of 10 people, what's the chances that, well, no, hang on, let me think about it. Let me write the tree a little bit differently. Yeah, no, I think that's it. Yeah, so like there's two possibilities. Either the builder will get 10,000. That's if they convince you to break the tie, but that only happens 25% of the time. Or whatever, 0.754, the builder gets 0. So, do you remember we have this thing called expected value? Do you remember how to calculate that? Expected value?
Yeah.
What is it? It's sum of p times x. So in this one it would be 0.246 times 10,000. So what's that? Oh no, I'm just making up my own one that's similar to this. 2,460. Yeah.
But why would you have to?
Yeah, I'll draw a little possibility here. Can I scroll down a little bit? Okay, so there's a couple of things that could happen here. Or I could draw it as a tree. So let's imagine that the builder, here's the builder, and here's you. If the builder pays you 2,460, that's actually not really that good for the builder because the builder was expected to get 2,460 anyways, just off of the probabilities here. So the builder's position would be 0 and you would be plus 2,460 because you weren't going to get any money anyways, you know. If the builder doesn't give you any money, then they could have 2,460. But then again, you haven't been bribed, so you have 0. So the best thing that might be to do for you and the person that the builder is bribing is to split this difference too. So you each gain the same amount. So if you bribe the person €1,230, that's good for them because that's 1,230 that they have that they didn't have. And it's good for the builder because it helps get the hospital built, but it doesn't equal so much money that it cancels out what they expect to get anyways. So in other words, you're splitting the difference, the gains between the two of them. So 1,230 would be a good amount for the builder to bribe. Don't worry about this. This isn't an exam one. I just thought it was an interesting one. Okay. What else do we need to see now? Yeah. Oh yeah. This much? This one? Which part do you need? Ah, yeah. I think this is from a lesson you missed. If you want to catch up on it, it's called binomial. We did that on, where was the first page we did that? It was 126, wasn't it? Yeah. 126. This is a Michelle, this is a formula that's in the formula book. So if you watch the video, you might be able to get it. It is in the formula book, isn't it? I've actually forgot to tell you what page it's on. It is? What page? Oh no, the formula in the formula book. Come here, Ahmed. Why are you late? Was there really? What street? If I Google this, will I see it on the news? You think so? Okay, sit down. But of course I can't give you attendance. What time is it? Not Japers, yeah. Okay. It's not in the formula book.
Statistical formulas are on page 6 and it's not there.
Yeah, it is. It's on page 7. I'm looking at it right in front of my face. It's on. It's just written a bit differently. Instead of writing NCR, they write N bracket X. And Q just stands for 1 minus P.
Where do you see it?
Can you do page 124, question 6?
Yeah. Do you think the answer's wrong or is it just confusing? Okay. 126, question 6, yeah? A waitress can serve up to 10 tables during lunch hour. The probability she will serve 0 tables is 0. So she always serves at least 1 table, I guess. The probability she will serve 1 table is 1 over 45. 2 tables is 245, and so on. So what's happening here is X P. Probability she serves 0 tables is 0. 1 table? 2 tables? And this continues all the way up until 10 tables. She gets a $5 tip per table, and she gets paid $4 per hour. Why did I ask that question? How many tables are in this cafe? 9. What I think I really meant to say.
And also, if you add 1 plus 2 plus
Yep.
2 to 9,
Yeah, that's what I was thinking. I should have said not how many tables are in this cafe, but I should have said what is the most number of tables she can serve. So I actually don't know that it's up to 10. I need to stop when the probability is 1. So I need to figure out when is 1 over 45 plus 2 over 45 plus 3 over 45. When do I stop? When does the total become 1? So what type of sequence is this? It's AP. And what's the A? Yeah, good. And the D? 1 over 45. So this is, the formula is n over 2, 2a plus n minus 1 times d. And you want that to equal 1. Yeah? Okay. Let's bring out that 45. Let's multiply by 2. So now that becomes 90. So that's 2n plus n squared minus n equals 90. So that's n squared plus n minus 90 equals 0. So 9 and 10. N minus 9, n plus 10. So obviously you can't have negative 10 tables. So the answer is 9. Well, my question would have been, what is the most number of tables she can serve? So the answer is 9. 9 is the most, because that will give us a total of 1. Okay, continue with the next part. So the expected number of tables, you remember the formula? It's sum of p times x. So the first one is 0 times 0, and then the next one is 1 times 1 over 45, and then the next one is 2 times 2 over 45, and then the next one is 3 times 3 over 45, etc., etc., etc. You have to do that 9 times. So I don't have my calculator open, but when you add that up to 9, what do you get? Looks like you get 2. So if you add them all up, you'll get 2. Okay. C. What's wrong? You're checking that it's 2?
Yeah.
Okay. Now, what's the formula for variance? That is this minus that. Remember that formula? So, let's calculate this guy.
It's 8.5.
Are you sure?
Yeah.
Are you sure? Oh, sorry, it's not 2. Thanks. What did you get?
8.56.
Are you sure? It's so big though. Okay, I'll trust you.
Oh, that's it.
Okay, thanks. Does anyone else want to check the calculation? Give me the calculator.
6.3.
I don't trust any of these anymore.
6.34. I did 10 over 45. That's
I don't need to check?
fine. No.
Okay. 6.34. Here you go. Okay. C, what is the variance of the number of tables she will serve? So you have to do expected value of x squared. So that would be 1 squared times 1 over 45 plus 2 squared times 1 over 45 plus 3 squared times, 2 over 45, 3 over 45, etc. minus 6.34 squared. I think this comes out to be 4.89. If you calculate it. You don't need to type it in, I'm pretty sure it's that, okay? D, what is the expected income? Well, what is our income here? I think I said in the question she gets paid $4 per hour plus $5 per table. So that's what our income would be, yeah? Now, the reason I have this is because I want you to remember this is the same as 4 plus 5 times the expected number of tables she'll serve. What's the expected number of tables she'll serve? 6.34. So that's $4 plus 5 times 6.34. So what's that?
$35.7.
So about $35, yeah? And lastly, what's the variance of our income? That's the variance of 4 plus 5 times the number of tables she'll serve. So that's the variance of 5 tables. And how does the 5 come out? Does it just come straight out? No, it doesn't.
It does.
It doesn't. It comes out as 25.
Oh, yes.
Yeah, wakey. 5 times the variance of the table, which is 25 times, what do we say the variance was? 4.89. Alright, so what's that then?
122.25.
Okay. Alright. Just before we finish, I have something important from Emer, which I need you to fill out before you go. Emer needs your GNIB number and your GNIB expiry date. Okay? So, if you can take out your card and, here, Mahmoud, or Mohammed, sorry. If you fill that out and pass it around. I have no idea.
Because the one on the left is the registration number.
Doesn't the number start with a letter or something?
Yeah.
What letter does it start with?
Oh,